Hello there. In this tutorial, we show about what is RAID, types of RAID. So RAID is the concept. It's as a full form of RAID and array of independent disk or RAID and array of inexpensive disk. So basically, it allows us to copy our database in one or more than one hard disk or storage device. Same way, if our computer have 2 or 3 hard disks, we can use types of RAID implemented. Basically, RAID can be used at the big organization, server level where database is very required, and basically for expansion of a database it easily required. So big organization afford RAID because since to implement some of RAID operation we require more than 2 hard disks or at least 3 hard disks. So first types will be disk panning. Now disk panning is we expand one of the volume uh, to form disk panning. Means if our uh, E drive of our hard disk is filling and require more and more space, then we can easily connect 2 or 3 hard disks to expand the size of E drive. So it basically it increase the volume size by connecting 2 or 3 hard disks, but basically it remains one volume only. So it's basically increased the size of the volume. So next we RAID 0. Now regarding disk panning, it don't provides redundancy. If any of the hard disk get corrupted, then database will be deleted and it will lost. We've lost the data. Now RAID 0 striping value. Now basically it store our data in a striping value, striping form at the hard disk. It also not provide redundancy. 2 hard disks connected, you can see in the diagram it basically copy data in a stripe form. So if we copy if we save notepad at disk at disk the database disk. So for example, if the disk 0 and disk 1 becomes E drive, so if we copy our database, so first it will copy to A1, then A2, then A3 and A4, A5, A6, A7, A8. It copy our database like that. See, mean you can see the sequence will be like that: A1, A2, A3, A4, A5, A6, A7, A8. So this is what RAID 0 striping values are about. So it also not having redundancy, not having redundancy, and even if any of the database and if any of the hardware get corrupted, the full database will be deleted. We can use maximum 32 of disk and it will fast as the read and write operation. RAID is basically provide redundancy. It perfectly mirror our volume. So if our disk 1, RAID 1, disk 1 is 40 GB and we connected disk 2 also 40 GB, then it will not give us a space of 80 GB but it will remain 40 GB. So this is what the mirror volume is all about, and it is a copy of a database. So if we save uh, any file at disk 1, it will be copied at disk 2, and 2 hard disks needed, and if any of the hard disks get corrupted, we will able to get the database back. Only thing is that disk This process, RAID 1, is costly process. RAID 5 basically store our data is a parity form. A parity form. So, for example, if we have 5 hard disks connected in our network, so it basically store uh, our database, a bit of database, a parity form, and uh, some way we can see A1, B1, C1, D1, the whole database will be connected, will be stored at fifth hard disk, and in a bit form. I mean, very small parity form. It will be copied. Same way, uh, disk 1, disk 2, disk 3, disk 5 data will be copied at disk 4. So very small form will create a parity. It will provide the redundancy, and if any of the hard disks get corrupted, then you will able to save database. So if and but you require basically hard disk, and you have to connect hard disk. Once you connect it, you will be get to normal. So it saved the database by in a parity form. So the whole mixture, whatever uh, will be the mixture, the whole mixture will be copied and saved in one of the hard disk. So parity will be in one form, in a one. Another types, and these types of RAID are basically not popular enough. RAID 2 is uses bit label striping, and instead of uh, bit label striping, and instead of striping the block across the disk, it means it basically it save data in a stripe form, not in a block form, and the stripes are in bit label. So basically, it uses our correction code and stores the information in the redundancy disk. It means basically it stores the error correction code only, not full data or not parity, but it stores the error correction code only. So whatever the database, whatever the redundancy disk is, it copy the whole error correction code. So it slow up the process, and somewhere it's not popular, and even it's not running nowadays. No one opting RAID 2. Uh, it it increased the read and write process, but basically it too much synchronized. Try to uh, label it. Now RAID 3 is basically create a parity form. RAID 3 it uses byte level striping and the block across the disk. It means whatever disk in the network, it will save the data in byte level striping. It stripes the bit across the disk. It means A1, A2, A3 will be saved in a stripe form of one hard disk, which is a redundancy disk. A4, A5, A6 will be copied in a stripe form in a one stripe form in their redundancy disk. So you can see in the diagram B1, B2, B3 copied in BP13, which is a parity form of this redundancy disk. B4, B5, B6 copied a parity BP46 in the redundancy disk. And it's again RAID 3 is not nowadays or running, but read and write it's okay. We can be easily uh, it it increase process, but somewhere it's again uh, too much synchronized, and same way synchronized, and so it slow up the process. The RAID 4 is again a block label striping, so it again is the same. RAID 3 is byte label striping, and RAID 4 is block label striping, and same A2, A1, A2, A3 will copy in the parity, B1, B2, B3 copied in a parity of readiness disk, C1, C2, C3 copied in a parity of readiness disk. Only thing changed is it saved data in a block level striping. The RAID 6 is basically dual parity, and it's same like RAID 5, but RAID 5 only have one parity level, and RAID 6 provides two parity levels. So A1 B1's copied will be at disk 4 AP, disk 3 AQ AP, and same way CD will be copied at disk 1. So it provides dual label parity. Again, synchronized label will be increased because of parity levels, and same way, not too much different, but basically people use RAID 5 more than RAID 6 because of synchronization. Now RAID 10 is basically nothing but a combination of RAID 1, and when 2 become RAID 1, then it becomes RAID 0, and basically RAID 0 is RAID 1. It means combination of RAID 1 become RAID 0, and that combination we known as RAID 10. This is not a concept. Um, Also, it's not nowhere it's written in the documentation, but somewhere uh, we need to understand, because in company label, basically server label, RAID 10 is used. So you can understand that RAID 1 is the copy of two disk, and RAID 1 is the number of two disks. So RAID 1, the combination will become RAID 0, and that combination will be known as RAID 10. So this is what it's not a concept, and nowhere in documentation we find RAID 10, but since it's uh, a thing to know, that I will explain you. So again, you can see it's just a mirror image of RAID 1. One hard disk copy of like 80 GB hard disk becomes 40 GB. uh, this 3 this 4 is same 80 GB hard disk become 40 GB. It's mirror file. So you can find RAID 10 in a big organization, a server label, where database very important. So this is where the combination of RAID 10, and hope you learned something about RAID label, and we will do practicals about the commonly used RAID, that is span volume, RAID 0, RAID 1, and RAID 5. So we will back with more on RAID label practicals. Thanks for watching.